Hello and welcome to today's ACM SIGSOFT webinar. This webcast is part of ACM SIGSOFT's commitment to provide value to its current and future members. The ACM SIGSOFT webinar series features speakers from the Future of Software Engineering track at the International Conference of Software Engineering, as well as select keynote speakers and distinguished paper authors. I'm Robert Dyer, Assistant Professor at Bowling Green State University, and it is my pleasure to welcome you today. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you will find a number of additional widgets and resources. If you're experiencing problems with the slides or audio, press the F5 key in Windows, Command R on a Mac, or refresh your browser on mobile devices. Or you can close and relaunch the presentation. Control Volume adjusts the master volume on your computer. If you have questions during the webinar, please type them into the Q&A box at any time during the webinar and then click the Submit button. At the end of the presentation, we will have time to respond to questions. This session is being recorded and it will be archived. You'll receive an automatic email notification when that archive becomes available. Today's presentation is Lies, Damn Lies, and Software Analytics: Why Big Data Needs Thick Data by Margaret-Anne Storey. Dr. Storey is a professor of computer science at University of Victoria. Her research goal is to understand how technology can help people explore, understand, and share complex information and knowledge. She evaluates and applies techniques from knowledge engineering, social software, and visual interface design to diverse applications such as collaborative software development, program comprehension, biomedical ontology development, and learning in web-based environments. In the past, she has investigated the role of social media in collaborative software engineering, improved visualization techniques, and social software to facilitate classifying diseases at the WHO. Peggy, without further ado, take it away.
Great, thank you, Robert. So thank you for inviting me to give this talk today and also for moderating my talk. And I also wish to thank everybody for tuning in this morning. So the focus of my talk is going to be on the role of software analytics and software engineering, as Robert said. And I wish to discuss with you today some of the interesting trends and concerns that I believe researchers and practitioners should be aware of and perhaps even planning for. But before I get started, I would just like to acknowledge some of my collaborators and also some of my colleagues at the University of Victoria and at Microsoft Research who have contributed to some of the ideas and thoughts in the presentation that I'm giving today. Furthermore, I will post my slides online after this talk, and I'll also post a link on my Twitter account. So my research, I've been, for the past 10 or 15 years, I've been doing a lot of research in the area of software engineering, and primarily focusing on understanding and developing tools to improve human and social aspects in software engineering. And a lot of the earlier research that I did was on software visualization, and some of these visualizations addressed reverse engineering architecture from legacy systems, and also developing visualizations to assist in program comprehension. And through that work, I became interested in developing visualizations to help in collaboration and to bring awareness of activities that developers are doing in teamwork. And this consideration of teams and how developers collaborate with each other led to further research that looked at the various different tools that developers use, the social tools and the communication tools that developers rely on to support activities such as code review and testing. And this slide that's visible right now shows a timeline of some of the varied tools that developers have used over time since the dawn of software engineering. And if I give you just a little bit of glimpse of some of the research that I've been doing looking at the more recent social media tools in software development, you'll see that we have done some research with Twitter. So we've done a study with actually over 10,000 developers to understand how they use Twitter to stay up to date on their project, and how they use Twitter to connect with other developers, and how they use Twitter to stay abreast of the latest technology trends. We also did some studies of tools such as Master Branch and CodaWall, And these tools help developers keep track of the activities that they are contributing to open source projects, but also to resources such as Stack Overflow. And they use these dashboards that these tools create to not only communicate what they are doing, but also to track and assess what other developers are doing. Another study that we did looked at how a crowd of developers documents open source APIs through Stack Overflow. Basically, through the questions and answers that they post on Stack Overflow, they provide a very rich form of documentation then that other developers can then use. And a recent study that a student of mine did was looked at how developers share tacit knowledge on YouTube. So YouTube, of course, presents videos, and some programming knowledge is very difficult to describe in textual form. And so a lot of developers are documenting their APIs or describing how to use technologies using YouTube and then sharing those videos with other developers so that they can learn. And more recently, we've been looking again at code review, but looking at how developers commit code and how they integrate code through pull requests on GitHub and the mechanisms and the factors that influence whether they commit or whether they integrate the code through GitHub. But all of these studies that we've been doing over the past 7 years or so are very much focused on a single tool. We looked at the activities the developers were doing through the lens of one of those tools, but it gave us quite an impoverished view of what was really happening in the overall kind of project or in the overall team. And if you look at this next chart here, this shows a similar timeline to the one that I showed before of how tools have really varied over time. So on the left-hand side, we have the non-digital tools going all the way back to 1968. And as we move forward, we see that tools became more digital, and more recently they've become highly social and support a lot of social activities and community building across the teams and across the community of developers. And some of these tools are designed for exchanging knowledge, that is tacit knowledge between developers, so face-to-face, or tools like Skype or Google Hangouts. Whereas going up, the next set of tools are tools that allow the developers to externalize information and knowledge about the code or the tasks that they're working on. So here we have tools such as IDE or tools such as Trello for helping people keep track of what's going on. And then the next level going up, we have tools that create community-based resources that developers across the community can use as a whole. So originally that was books, and then we saw Usenet coming, and now more recently we see GitHub and Stack Overflow and Hacker News being used to create these community-based resources for developers. And then on the top we have tools that facilitate knowledge about the community and about networks. So societies were used originally, but more recently we see tools such as LinkedIn and Facebook and Meetups being used for that. So we became very interested in this very rich and diverse constellation of tools that the developers were using, and we wished to really understand what kind of a role all of these different tools were playing in software development activities. And so we've been surveying developers over the past 3 years, and we've done the same survey 3 times, and so far we've heard from about 2,500 developers, and we've asked them questions about what are the activities that these developers do, and what different tools do they use to support these activities. And one of the things that we found out from our earlier studies of looking at Twitter and Stack Overflow and YouTube is that it isn't just about writing code or committing code or testing code, but developers care very much about other activities such as staying up to date with the latest technology and trends, learning new technologies, discovering other developers that may have knowledge that they care about, connecting with those developers, and even publishing their own activities and accomplishments, and then using that to reach out and to connect and to coordinate with others. And so through our survey, we asked different questions about these activities, and we asked them which tools they use. And so, for example, for learning, we found that developers use a very wide range of tools for learning. In some cases, some of them said they use 10 or 12 different tools. So, of course, web search is a key tool, Q&A sites such as Stack Overflow, but they also rely a lot on code hosting sites such as GitHub for learning about their projects. In terms of coordination, they also use a wide variety of tools for that as well, such as private discussions and microblogging, tools such as Twitter, as well as code hosting and face-to-face. And for connecting with other developers, they also use the same kind of tools such as microblogging and code hosting and face-to-face as well. So overall, from this study that we did, we found that social tools facilitate what Jenkins called this participatory culture in software development. And this participatory culture brings with it a lot of support for the social creation and sharing of content, as well as informal mentorship from experts to novices, and awareness within the community that contributions matter to one another. And although we've been doing a lot of our studies through GitHub, so looking at developers that also contribute to open source, I should mention that most of the developers also contributed to industrial projects that were not open source. So many of our findings apply beyond just open source developers. So this participatory development culture is now quite widespread, with developers wanting to learn from other developers and connect with other developers. We see the rise of the social programmer. One challenge that we've been facing, though, is how to study this complex and diverse participatory culture that goes beyond just the team boundaries. And that if we just look at a single tool or we look at a single set of artifacts trying to understand what's going on, it gives us a very impoverished view. And we need to take a step back and really sort of look at what is the big landscape, who are all of the actors or the contributors or the stakeholders. So users, for example, may be regulating the features that are added to a system. What are the communities of practice that the developers are part of beyond the team? And what are the different tools and channels that they use, not just the tools that are online that we can look at, but also how do they use face-to-face or other channels? And what are the different artifacts that they create? And then through all of these, we look at what are the practices such as Agile or the activities that are fostered or shaped by these different tools and channels that they use. And part of the goal, of course, of doing the research that we do, and a concern of many practitioners as well, is that we are trying to address these very competing and diverse concerns in software engineering. So on the one hand, we're hoping to lead to code that is faster and cheaper to produce, and from the user's perspective has more features and that it's more reliable and secure. And on the other hand, we're caring about the developers. We're caring about making them feel more productive. We're caring about the fact that they want to learn more, they want to have more skills. They don't just necessarily care about how much they're paid, but they also care about the work that they do, whether it's interesting work and how connected they are to other developers in their community. And then on the other hand, we have concerns from the organizations of the communities, which may relate to things like attracting and retaining contributors to their communities or employees to a company, and how to encourage this participatory culture that we talked about and how to increase value from the connections within that community. So a lot of researchers, myself included, as well as practitioners, are looking to find the answers to addressing some of these concerns in the wide range of data and the vast amounts of data that we now have available to us from the tools, the various tools that developers use, tools such as GitHub and Stack Overflow. And we're asking ourselves, can we get the insights from this almost tidal wave of data to bring us understanding how to improve the software development process? And in today's talk, I want to say that yes, we can get many of the answers from software analytics, but that we need to be careful that too much focus on the data and the machinery can maybe blind us to things that are perhaps not blatantly obvious or that are perhaps more subtle below the surface. So I like to sail. I'm a sailor. And among sailors, we often joke that whenever one of us hits a rock, we'll say, well, were you staring at the GPS when you hit that visible rock? And unfortunately, the answer is often yes. We were looking at our machines instead of looking out the window. And so one of the takeaway, or the key takeaway from my webinar today, is that we have to be careful not to be blinded by the data that we have in software engineering, and that we have to watch out for those rocks and the less obvious things that may be lying below the surface of the data that we have available to us. So the title of my talk is about big data and thick data, and I realized that a lot of people have not heard the term thick data, so I thought I'd better describe it early on in my talk. So thick data really refers to the kind of data that social scientists will collect. So supposing you're trying to understand the dynamics, the social dynamics, and what's really going on in the skateboarding park, the best way to do that would be to go into the skate park and observe what's happening to the skateboarders interacting with their friends, how they practice new skills and how they have fun, rather than bringing, the lone skateboarder into a sterile laboratory and interrogating them. And so the kinds of data that you can get from the environment through a technique such as ethnography is you get this very rich and thick data, descriptions about what is going on that bring you insights that can help you understand perhaps the other data that you have. And I came to this understanding that we needed more than just, the data, but we also needed richer insights when we were doing our Twitter study. At first, I wasn't a Twitter user, and I was trying to analyze the data from Twitter that developers were exchanging with each other. And I realized I didn't understand a lot of the lingo that was used. And so to understand and to be able to analyze the data and to understand the nuances of what was going on, I needed to become embedded as a Twitter user to really understand what was going on. So that's what I mean when I refer to thick data here. So as an outline for the rest of my talk, I first want to give a bit of a history of this area of software analytics and software engineering. The term software analytics is relatively new, so I'll go back in time and just sort of show what areas of research that came out of and how that is implied in software engineering. And I'll also talk about some of the risks from software analytics, and that's the key, I guess, takeaway from my talk today. And then I'll touch on why big data needs thick data. And I hope to, throughout this talk, consider both researchers and practitioners. So let me start off with talking about this history of software analytics. And so if we look at software analytics, its roots really come from consideration of metrics, which came about in the 1960s. And the consideration on metrics first came about from the realization that a lot of the effort of developers was going to be spent in the future in finding errors and perhaps even counting those errors in their own programs. And it's attributed often to Wilkes in 1949, who had this quote that he realized a lot of his time in the future was going to be spent finding errors in his own programs. And so this came to, sort of led to the realization that understanding features about the code was really important. And DeMarco in 1982 told us that, well, if you can't measure it, you can't manage it. So this led to quite a bit of research and quite a bit of attention in practice in understanding the roles of metrics. And so why were metrics promoted? Well, they were to discover facts about the software engineering world, perhaps also to steer the actions of developers, and perhaps even to modify human behavior. And metrics can be used by individuals to understand what it is that they're doing themselves, as well as teams, but also companies and perhaps even external organizations. And there are many different types of metrics. So some relate specifically to the product, to the software product. So lines of code is one, or thousands of lines of code. There are also metrics that try to measure the complexity of the code, metrics to measure object-oriented properties, or metrics maybe to count the number of defects. But there are also metrics that look at the process, so deployment, code review, how often code review is done, how much testing is done, as well as metrics to measure agile practices. And some of these metrics refer specifically to the productivity. Productivity sometimes is measured in terms of lines of code, sometimes it's in mean time to repair bugs that are found, and sometimes it's measured in terms of the number of commits that are made to a repository. And other developer metrics are sometimes used as well, so the skills that a developer has, or the number of followers that they may have, or there's also some recent work looking at the biometrics of developers to look at the stress and the activity that they're under. And then there are other metrics that look at cost metrics and models as well. So in terms of how successful metrics have been in the research community, they've definitely been successful if you look at the number of papers that have been published and referenced in the research community. There's certainly been very many of them, and in practice too, in industry, There's certainly been very widespread adoption at large and small companies, and many case studies have been published on the role of metrics and what they've brought. For example, many case studies at HP. And these metrics have been integrated in software engineering tools as well as IDEs and other tools. And initially when they were used, there was a lot of focus on the product rather than the process. That has shifted over time. And initially, the use of the metrics was perhaps a bit poorly used, but this also shifted in the 80s as well by research by Basili et al., which really pushed towards using what's called this goal question metric approach, which really recommends having a goal behind why you're using the metric, articulating your question, and then linking those goals and questions to the particular metrics that are being used. If we look at one example of a metric, probably the most common one that people may refer to, it's lines of code. And the reason that it's used so often is that, well, it's easy to calculate, it's easy to understand, and it's even easy to visualize. And it is descriptive of the product, and in some cases it's been used as a proxy for developer productivity. And it's even been found to correlate quite highly with complexity measures and with the number of bugs, not surprisingly. But it's also been well recognized that it's not a very effective measure, particularly for productivity. And I really like this one quote by Bill Gates: measuring programming progress by lines of code is like measuring aircraft building progress by weight. So it's certainly a poor metric in that sense. So, but of course other metrics that I'll touch on later are perhaps more successful at bringing insights into development process and into the product itself. So the role of metrics grew into, I believe, into this area of mining software repositories, which came about in the mid-2000s. There's been a conference in mining software repositories since the mid-2000s. And this consideration of mining software repositories was really looking at analyzing these outcroppings of past human behavior. So development is a human activity, and these human activities lead to these traces behind about what humans are doing. And as researchers, we were pretty excited to have access to all of this data that before the mid-2000s wasn't really that readily available to us. And so many researchers thought, well, we have all this data, and now what do we do with it? Although I think practitioners were less concerned with, the problem is what to do with the data, and more that they had, sort of real problems in terms of developer productivity or, buggy code. And as I mentioned, this conference series has been around since 2004. And there are many different kinds of data that we have access to. So I mentioned some there, some program data. We have runtime traces, program logs, performance logs, continuous deployment data. We also have a lot of data from the users, their usage logs, surveys, what they're saying on Twitter, data from testing, such as A/B testing. And of course, in terms of the developer activities, we have much data here. Check-in information, their commits, the test cases they run, the results of those test cases. And we even have a lot of information about the communication between developers, as well as how they use social media. And from the mining software repository communities, we have many different techniques that have been borrowed from other areas of AI and machine learning, so classification and clustering and natural language processing, searching and mining, as well as qualitative analysis techniques that have been brought in to apply to software development challenges. And the benefits of mining this trace data, of course, is that we do it after the fact. So after the developers and the users have created this data, so we're not interfering with their natural activities, and so they are not reacting to it. So what they are doing is more natural. And the records are made by the participants. So as researchers or as practitioners wishing to understand this, we don't have to go to a lot of effort to create this data. It's being created for us. And one of the benefits is, as researchers, and perhaps one of the pitfalls, is that this data is very, very easy for us to collect. And so we tended to collect it and tended to analyze it to see what we could learn from it. And looking back at the metrics, DeMarco in 1997, after much reflection on the role of metrics, he said back then that he felt that the only metric worth counting is really defects, because that's sort of a critical concern in terms of how many bugs does a software product have. And why mine and measure information about bugs. And looking at bugs has been a major concern in the mining software repository community. And some of the reasons are from the developer perspective. They want to understand how many defects are they adding themselves to the code. Managers care because they want to evaluate how the product is doing, and they want to understand the product status. Are they getting better? Or maybe they want to use some techniques, some analysis techniques to help them predict the reliability of their code in the future. So looking at one example from the mining and software repositories community, bug prediction has been one technique that's seen a lot of attention, and there's been a lot of development of models to predict bugs. And in fact, these models show quite a bit of promise. Some of these models are based on ownership, looking at if there's a lot of co-ownership about for certain code. That tends to lead to higher number of bugs. Code that's been changed a lot or churned a lot tends to have more bugs. And code that has tangled dependencies with other code tends to also have code changes. But although there's been quite a bit some success, there's also been some limitations in terms of the models don't always clearly replicate across projects or across organizations. And sometimes practitioners have complained that some of the research we as researchers have done has poor actionability, and that they say, well, we already know which of our models are buggy. We know that. Tell me something that I didn't know. And so this focus on looking at what we can see from the tools that we can mine has been discussed quite a bit by some researchers in the community. And there's this landmark paper by Aranda et al. That looked at what they referred to as the secret life of bugs. So that's all of the things that occur behind the scenes, behind the bug tracking tool. So the activities that happen around a bug, such as face-to-face communication between developers, that is also really important for us to look at and to understand what's really happening to cause these bugs and what's really happening in terms of addressing them. So I've looked at so far metrics, the metrics research, which really focused on looking at the measurements. And then I looked at how the role of metrics grew into the mining software repositories research, which had, I guess, more of a focus on measurement, or not measurement, but techniques and algorithms for looking at those measurements. And now more recently, this area has grown into what's being called a software analytics since the early 2010s. And there have been many definitions, most of them since about 2010, that have come up with what software analytics means. And these definitions by these different researchers all have one thing in common, in that they refer to actionable insights. So we can see this trend from metrics to the mining to software analytics towards an increased emphasis on getting actionable insights for practitioners and for developers, and also for researchers as well. And the software analytics and indeed the mining work that's been going on has of course been informed by the data science movement, which is being applied in other areas of science as well as in economics. And data science really brings together three skills. So it brings together math and statistics knowledge, as well as hacking skills, as well as our computational skills, as well as a reliance on substantive expertise in the domain that's being studied. And the data science movement, of course, recognized that there are some dangers when you do not have sufficient skills in all of these three spheres, and that really you need all of these three aspects to enable you to do good data science. So the goals of software analytics actually closely mirror the goals from the mining software repositories work as well. And they're basically to improve the quality of the software, to improve the experience of the users, and also to improve developer productivity. And throughout my presentation, you'll see that I have links to resources that give more information on what I'm talking about. And so here's one here on a tutorial on software analytics that I suggest looking at if you're interested in this. And there's also this book, The Art and Science of Analyzing Software Data by Bird et al., which is just recently published. And this book talks about the data science spectrum, which looks at how you can explore and analyze and experiment with data to inform, to look at and to understand what's happened in the past, but also to maybe bring alerts or to compare what's going on in the present, but also to be able to forecast and to be able to simulate what might happen in the future. So there's this sort of broad spectrum of these different techniques that are being looked at in software analytics. So software analytics, of course, is playing a very key role in automation in software development. And what's really important here is that in many projects in large companies or even just in open source community and many of the open projects that are out there, these projects are scaling, need to scale to support contributions from thousands of developers. And there's no way that one or even a few developers are going to keep all of the information in their heads about what's happening in the code or what's happening in other activities. And so automation is simply required. And so software analytics can play a key role in this automation. And the goal there, of course, is to optimize the competing concerns of the quality of the product, the time of the developers, and the resources that are being used. And so data scientists are now playing an increasing role in managing and measuring the impacts of this automation and of software analytics in improving software engineering processes. And there's a paper coming out at ICSE in 2016 by Kim et al. Later this month. ICSE is the International Conference in Software Engineering. And this paper describes the emerging but the well-established role of data scientists at Microsoft and how they are playing a key role at understanding the role of software analytics at Microsoft in these projects. And it's not just companies, large companies that are relying on software analytics. Small companies are as well, and some companies even provide services in software development analytics. Bittergia, sorry, I'm probably not pronouncing it right, is a small company that actually grew out from researchers from the mining software repositories community, and they provide a service on the web that allows small companies to be able to analyze and look at their progress through the code. And this is particularly valuable for developers and managers that are wishing to, say, for example, argue for more resources towards working on their projects. So looking at a typical question that one may ask in software analytics, and one such question is, does increasing test code coverage increase reliability? And earlier on there was some understanding or some belief that actually doing that if you had excellent code coverage, that the number of bugs in your project would go down. Well, software analytics has brought us some understanding that actually no, that if you increase your test code coverage and focus too much on the test code coverage, that you may in fact not improve your reliability, and you may in fact increase the presence of bugs. And so there's research by Malkus et al. that showed this, and actually they showed that there were quite different results in different projects. And part of the reason that this may not always hold is that if you spend time or waste time testing simple code, that reduces the amount of time that you may have on debugging the complex or the parts of your code that may actually have more defects. So that's just a brief overview, I guess, of the role of data science and software engineering, from metrics to mining software repositories to going forward now where we are with software analytics, where there's an increased focus on the practitioner. So for the next part of my talk, I want to emphasize and discuss with you some of the risks from applying software analytics. And these are risks that other researchers and practitioners are talking about. And I just wish to bring them together here and to really emphasize them and make them a primary concern, rather than a sort of after the fact, let's do software analytics and then later on let's worry about these. But I'm suggesting that we should pay attention and be aware of these risks up front. So these 5 risks, I'll go through each of them in time, and as I mentioned, they are not the only risks that one needs to pay attention to, but they are just ones that I think are of key importance. So the first one that I want to talk about is the trustworthiness of the data. And this really relates to how representative of the data is it of the construct or of the phenomenon that you're trying to study. So I already touched on this when I talked about lines of code and using that as a way to measure developer productivity, that it's not necessarily a good way to do that. But even other measures, such as the number of commits, perhaps is not a good measure as well, that it doesn't really measure all of the other activity that they're doing, such as networking with other developers or spending time learning what technologies, say, their organization should be aware of, or knowing what they should be using down the road. And there's also issues with the completeness of the data, that the data that you have may not tell the full picture, that there may be things that are just left out and somehow don't tell us all of what's going on, such as the Secret Life of Bugs study that I mentioned earlier. It doesn't tell us the bug tracking tool doesn't tell us the full picture of what's going on. And that there could also be inaccuracies. Much of this data is produced by humans, and humans, can exaggerate from time to time and may have skewed opinions. And that we need to be careful, as Harper et al. Mentioned, that we don't treat these humans as rational animals and assume that they have, the best interest of the project or the company at heart. They may have other interests. They may, be more interested in developing their skills or in even potentially competing with other people on their team. And so we need to be very careful in just using this data and not understanding maybe some of the hidden motivations that are there. There's this paper that appeared in Mining Software Repositories in 2014 that talks about the perils of using GitHub data. And a lot of researchers and a lot of companies too are using the data from GitHub to try to understand what's going on. But we need to be careful, because history can be rewritten on GitHub through squashing commits. A lot happens outside of GitHub, and a lot of the stuff that's on GitHub, a lot of the repositories are not necessarily, sort of full-scale development projects, and they may be even, inactive, and some of them, most of them haven't even been forked. So this paper raises some of these issues. The second risk then is looking at the trustworthiness of the results. So the first risk was looking at the data. And this one is looking at, well, we've got the data and we've analyzed it. How much can we really trust the results? And the first one I want to talk about here is researcher bias, whether it's, researcher from academia or a researcher at a company, that the researcher may in fact bring their own biases into play when they do their analysis of the data. And there's this very interesting paper by Shepard et al. Where they looked at, they did a meta-analysis of 42 studies that applied different techniques on classifiers for understanding defect-prone software components. And what they found was that the different classifiers had little impact on the performance of them, but actually that the research group that used the techniques had more of an impact on performance, indicating that there is some potential research bias there. And we also need to be careful of confusing correlations with cause and effect, which, most of us, of course, have heard stories about this, but also need to be cautious about getting or finding small effects from big data. This is one of the risks of analyzing big data. And the New York Times had an article, they were referencing a paper by Marcus et al., which showed that from 2006 to 2011, that the U.S. murder rate was well correlated with the market share of Internet Explorer, as both went down sharply. But of course, it's unlikely to be any causal relationship between the two. But this demonstrated that you can have this small effect when you have big data. And then we have to be careful about inappropriately generalizing our results, say from open source to industrial projects, or from one industrial company to another, because the context is very different, as well as the instability that you may have about your conclusions, that these conclusions just may not hold across projects. So looking at this risk number 2, I really like this quote that I want to share with you. All models are wrong, but some are useful. So I just want to emphasize that, although we know that there are limitations with these models, that they can still be useful, and that we need to be careful to think about what are the variables that are used in the model, and more importantly, which variables are not considered in the model, which variables can we not analyze through the data that we have available to us. So now moving to the third risk, I want to talk about some ethical concerns, which does get quite a bit of interest, although I still think as a community, both in research and practice, we still need to work towards having some well-established practices and frameworks in place for understanding the ethical concerns from using the data that we have available to us. A somewhat obvious one is that a lot of the data that researchers are analyzing is publicly available, so it's data on GitHub, data on Stack Overflow or on Twitter, and it's true, this is public data and the developers know that, but at the same time when they put this data there, maybe their project is open because it's free on GitHub, and they aren't really considering that later on down the road somebody is going to analyze what they're doing and look at all of their commits on GitHub and look at what they're posting on Twitter and at Stack Overflow, and really that through that we can do what's called surveillance at the level of the individual. And so there are certainly some concerns there for researchers, but perhaps also in companies, a lot of developers may not realize that that there are the ability to do this kind of surveillance at the level of the individual. And when it comes to if you're an employee and you're being assessed by your manager, you know what their bias is. They're human biases. We're familiar with those. But if there's some algorithm being used in the background, they're opaque and we don't fully understand what the biases that those algorithms bring. So there's a need to be cautious there because there's an effect on the people that these techniques are being used on. And many of you may have heard about this infamous Facebook study from 2012 where data scientists skewed, for almost 700,000 Facebook users, they skewed what they saw when they logged into the service, and some of them were shown happier and more positive posts, and some of them were shown sadder than average posts. And what they found was after a week that these manipulated users were more likely to post either positive or more negative words themselves, so it actually had an effect on their mood. And there was a big outcry about this, and it was kind of interesting in a way because the effect size was very small, again, from the big data that was available. But the biggest issue was that users suddenly realized that data scientists could kind of manipulate their feeds and that they didn't realize that this could happen, although, probably the policies in Facebook allow this. So some caution is needed here. Then the fourth risk is looking at unexpected consequences from this. So one point I want to make here is that, I'm quite interested in the role of gamification and transparency on gender and other minorities. And although on the one hand it's good to sort of bring out that there are these issues, on the other hand, by publicizing them, we're perhaps scaring away minorities even more from contributing to these projects. And there are also some issues in terms of gamification. Developers can game the gamification elements themselves, so they can make smaller or even, silly commits to improve their profile. And we see this in companies when people are coming up to be assessed for salary, that they all of a sudden make lots of commits, but really, the amount of work they're doing doesn't really change. And that we need to be careful that whenever we have incentives in place, whether they're explicit or implicit, that it may have a negative impact on the company. So you may, on the one hand, sort of, reward people when they do lots of code review, but may not, realize that some developers are spending a lot of time face-to-face, say, helping new novices in doing a code review, and that doesn't show in the system. So as I mentioned at the beginning, there is some research that I've been involved in that looks at how developers mutually assess each other and how employees assess each other using tools such as CoderWall and MasterBranch. And we don't even need to, look that far to see just tools such as GitHub. They have a contributing graph which shows how publicly how many projects you've contributed to and what kind of work that you've been doing, and many developers are sort of pushing back against this and saying, it's stressing me out seeing what my colleagues or the people that I follow do, and I'm feeling inadequate. Even though they recognize that a lot of the work that they do is not public, there's still this pressure from these visualizations that are doing this analytics in the background and providing views of what they're doing. And there was a study actually at Microsoft too that looked at what are the wise questions that data scientists at Microsoft should be asking, as well as the unwise questions. And indeed, many of the unwise questions that came out related to measuring a developer productivity. So for the last risk, one of the things that I think we need to be really careful about is that big data can't always answer what I'm calling big questions. In some cases it can. So if you're traveling to London, maybe some of you are in London already, and you want to know how to get from point A to point B, would you trust Google Maps or would you trust a London cabbie? Well, some of you may trust the London cabbie over the big data. However, if it looked like Mr. Bean, perhaps you wouldn't. But if you were sick and you had a disease or your child had a disease, are you likely to trust the big data or are you likely to trust a specialist that has had 20 years of experience of treating this disease? Well, actually, you're probably going to trust both, right? You're probably going to trust the specialist that is also paying attention to the big data and the analysis of the data that's possible through that. So big data alone can't answer these big questions. And if we look in software engineering, what are some examples? I've just put a few here, and I'm sure everybody out there has their own sort of favorite questions or burning questions that they have about software engineering. So some examples of questions that I think that big data today can't do a good job of answering is, what is a good architecture to solve problem X? What makes a really awesome programmer? Is it their knowledge of an API, or is it how effective they can connect with other developers and how they can curate their network of people they follow on Twitter to know what's the next big thing they should be paying attention to? Or how do you build a great development team? Can you figure that out from your data? Actually, Google has a paper, I've got a link to this at the end, where they needed to use ethnographers and social scientists to figure out what really makes a great development team. And how is programming knowledge distributed? And what is the ideal software engineering process? It's still an open question that many big companies in a recent symposium were still grappling with. They don't know. They all do different things. And my own question I'm trying to understand is what tools and practices support this development process that I referred to. So these big risks, or 5 risks as I mentioned, have been talked about others, and I have references at the end that talk about these and other risks, as well as potentially some rules to follow. So for the last couple of minutes in my talk, I want to just emphasize why I think big data needs thick data and why indeed thick data needs big data. It's a bit of a two-way street. So data scientists typically start with the data rather than starting with the problem. I mean, this is a bit of a generalization, of course. But even looking at the quotes that came from the study of data scientists at Microsoft in this paper that I mentioned is forthcoming, you see quotes such as, "I love data, I love pattern." It's really what turns them on, right? That this kind of data that's out there and the patterns that are there. And this is not unusual. And in fact, John Snow is often credited with being one of the earliest data scientists. And his visualization of data helped convince people to shut down the Broad Street pump to stop the spread of cholera in London in the 1850s. And this example is often given of the role of the power of data science as well as the power of visualizations. But actually, he didn't start with the hypothesis that the pumps, the water, that cholera was spread through water. People in those days actually initially thought that the spread of cholera happened through the air. But he came up with the hypothesis that it came from the water, but from talking to people and realizing that there were clusters of cholera around this Broad Street pump, which led to him then analyzing the data and then shutting down the pump because of it. So this makes me this is leading to me suggesting that the 3 areas for data science, math and statistics knowledge, hacking skills, and substantive expertise in the domain is not sufficient, that we need to also bring in expertise from social sciences, and that we need to really find ways to model these social systems that take into consideration the context and the social and the human activities that are going on. And I like this quote here, most big data is social data. The analytics needs serious interrogation, that we need to be careful about how we're analyzing this data. And as I mentioned, thick data is this rich kind of data that gives us explanations, gives us insights to human motivations, leads to recommendations that may not be evident in the big data. It gives us maybe more questions for us to look at rather than answers. It gives us insights into the variables that are there for a model or the variables that maybe we can exclude safely, as well as insights into future challenges. But I need to emphasize here, of course, that this kind of thick data also brings with it its own limitations. And so that's why I strongly believe that we need to combine both thick data and thick data so that we can offset the limitations from both of these. And I'm not sure if many of you have heard of this term ethnomining. It's a relatively new term coming from the social sciences, where they are promoting, combining the ethos of ethnography interleaved with the data mining techniques around the behavioral and social data. So this is going beyond just mixed methods where you do a survey and then you look at the data and then maybe you go back and do a validation survey. It's really talking about this tight coupling and integration where you're using the thick data to inform storytelling, to support the numbers, and vice versa, and where maybe you use visualization of the big data within tight loops of eliciting and reporting the results with the participants. And we've been starting to use this technique in some of our research. This is an example of a study that we did of looking at how developers tagged work items in the JAS development environment. And from coming up with this, from mining this data, when we looked at it, we saw that there was this term Polish, and we thought, oh, that must be to do with globalization. But in fact, then when we created a visualization, so this shows an interactive visualization that we gave to developers when we then went and did interviews in the workplace with the developers, we were able to find through showing this interactive visualization with them that in fact Polish was Polish and was to do with the user interface. And by giving them this very rich interactive visualization of the data, we were able to glean a lot more about what was going on, about the role of using tagging in the JAS development environment. So of course there are a lot of challenges ahead. We have big data. We now have the ability to collect big, thick data even, and that we're living in this era of rapid pace of change. So the studies that we did of looking at tools looked at, for example, the different tools that developers used, and we saw that it was actually unstable in terms of the tools that they were using. And our survey didn't ask about tools such as Slack, which was an emerging busy tool that developers were using. And in fact, looking at Slack is one of the things that we're doing now, because Slack brings together automation and software analytics embedded into the communication between developers. And I really like this quote by Kevin Kelly where, he says, you will be paid in the future based on how well you work with robots. And I think for developers, this is so true, that developers in the future are going to have to work with this software analytics and this automation to really improve how it is that they're doing software development. So the key takeaway from my talk is that big data needs thick data, and that if we change the instruments that we're using, that we may change the entire sort of notion of theory that we have that goes with them. And that the future of data science in software engineering is in growing what we're doing with software analytics, but paying a bit more attention to the thick data that we have out there for bringing insights to the analytics that we're doing. And so I'll close there, and I look forward to hearing some of your questions or comments. And as I said, I will post a link to my slides on Twitter. And I have quite a few references to some of the resources that I mentioned during my talk. Thank you.
Thank you, Professor
So over
Storey.
to you, Robert.
Yep. So the first question is that there seems to be some confusion between the term mining software repositories and the term software analytics. It seems to many people that they may do the same thing. Could you please explain how they might differ?
That's a really good question. And in fact, they really do the same thing. The term software analytics has just sort of emerged in the last few years. And I mean, if you think about the phrase mining software repositories, it focuses on the solution or the technique rather than what it's trying to do. And so software analytics is really mining software repositories in action, but doing it in a way that is really focusing on making the results more actionable. They are not distinct terms, or they are not distinct activities.
All right, thank you. Let's see here. What do you think of various automated software that's actually being developed currently to assess computational thinking in students from age 5 years and on, based on the code that they actually write?
Wow, that's a really great question, and I wish the person who asked it could give me some more insights on the research that they're referring to. I'm not familiar with looking computational thinking from children. I certainly think that the automated techniques that are out there can bring very rich insights into understanding how developers and how novice developers are learning, or even how children are learning, coupled with the research that's going on with looking at brain science. So there's some really exciting research right now that's looking at fMRI imaging and understanding which parts of the brain are being used, as well as biometrics. So bringing that together with automated techniques that can understand what kinds of errors people are frequently making, coupled with what's going on in people's brains, I think brings amazing future insights, and probably will lead to improvements to programming languages, to pedagogy, as well as to the tools that are being developed. We're just at the start, I think, of that. Great question.
Okay. So we have an interesting question from somebody at Google, and they state that most of data science seems to be hacking things together using various scripting languages with little or no regard for traditional software engineering best practices. Do you have any insight on how we could instill standard software engineering discipline into the data sciences?
Wow, great question. I agree with what's been said. I think that with any area of science that grows very quickly, there's a tendency maybe to not do things very rigorously and not do things in a very principled way, or thinking clearly about the impacts of that. I think that going forward, we need to step back from analyzing the data just because we can, just because it's there, and because we have these algorithms that we can just throw at that data, and that we do really need to step back and think about, okay, really, what are we trying to achieve here? What are the principles in our organization that we value? What are the software engineering best practices that we believe in? And stepping back and looking at those, and not just looking at the data, but talking to people and studying people in the workplace to understand how those principles are being applied and how to study them. So I think that looking at this thick data and really getting people to hit the pause button, I think is the first step. Great question.
All right, so I was wondering, in maybe just 1 minute, could you give a couple examples of some of the automated software that exists for doing this type of analytics?
Yeah, so there's techniques that look at continuous integration and look at as patches or as code is being committed to the repository, will flag bugs in the code, and will bring recommendations to the developers about which parts of the code they should be looking at. There's actually many recommenders. There's a book actually on recommendations for software engineering that was edited by Martin Roviar that talks about many of these techniques for coming up with recommendations that is based on analyzing the data from the repositories. So some of these recommenders can suggest, which code should you be looking at next, or which code is more likely to be buggy, or which code should you test, or recommenders in terms of if you've made changes to your system, which experts should you ask to review your code. So there's automatic techniques that will suggest to you these developers are developers that have worked on this code before and would have the expertise that you need for reviewing the code. So yeah, those are, you said 1 minute or less, so that's about a minute.
All right, thank you. Okay, we have time for one final question. When working with, I'm sorry here, wrong question. So what impact do you think the Agile methodology has had on attitudes towards designing artifacts and documentation? And specifically, do you think that attitude varies across community? Example, novice Agile developers versus experts versus people that teach Agile versus people in academia?
Okay, so that really isn't something that I have looked at myself very closely. I mean, obviously I've observed it, There's lots of research that reports the impact of Agile on documentation. I mean, one obvious thing is that documentation in the Agile sense in terms of the code should be self-documenting, and the test cases are a form of documentation in an Agile development process. In terms of our novices, when I teach, I usually encourage the students in most of the courses that I teach to follow an Agile approach, and for them to be tightly working with users of their program, and to be basically discovering requirements, being driven by the user in terms of the requirements of how their system is used. And so it's not creating documentation up front, but creating forms of documentation as it's needed in terms of the code and in terms of the test cases. Looking at what's happening with Stack Overflow, I think a really interesting line of research could be to look at how resources such as Stack Overflow and how the crowd of developers contribute to blogs and YouTube and so on, how all of that together plays a role within an Agile organization. I haven't done that specifically, but I think that would be very interesting work. Great question.
Right, well, thank you very much. I'm afraid we've run out of time today, so I would like to thank Professor Storey again for your informative presentation and insightful answers to the many questions. And a special thanks to each of you for taking the time to attend and participate in today's webinar. On behalf of SIGSOFT, Dr. Storey, and myself, thanks again for joining us, and I hope you'll join us again in the future. This concludes today's webinar.